All right, today we are going to review dividing polynomials with long division. There's two different ways to divide them, long division and synthetic division. Long division works for everything you want to divide. Synthetic division does not. Synthetic division is good to know, and we will talk about it tomorrow. But if all else fails and you only know one, it needs to be long division. Okay? All right, and I think this is something that I enjoy doing. I think because it looks so hard, and it's really not. Okay, it's really not as bad as it looks. So we're going to start by dividing something you learned in elementary school. So we're going to take 5,467 divided by 13. So we know we do 13 divides into 5,467. So we're going to do this just to talk about steps, because the steps that we take here are the steps that we take for polynomials. Okay, it just looks different, but really it's the same process. Okay, so when we do this, we take this is a 2-digit number, then we take the first 2-digit number and try and divide it in there, right? Because obviously 13 doesn't go into 5. So 13 will divide into 54, then I have to decide how many times, right? So 13 times 3 is 39. If I had another 13, that would give me what? 52, so it seems like 4 would be a good thing. Do I get to put the 4 wherever I want to up there? No. I put the 4 above this 4, right? Not because they're both 4s, but because I'm dividing into 54. Multiply this and I get 52. Then what do I do with those two numbers? I subtract. Okay, I subtract, and this gives me 2, and then I bring down my 6, right? 13 goes into 26 how many times? 2. So 2 times 13 is 26. And then I subtract, which is the same thing as just changing the sign on that number, right? And then this leaves me with 0. And I bring down my 7. Okay? So 13 doesn't go into 7, right? So I'm done with the remainder. So is my answer 42 with some sort of remainder? No, because one of the reasons you line them up is you have something missing here, right? 13 goes into 7 how many times? 0. So there's a 0 here. That 0 is very important, right? And then, obviously, when I multiply it back, I have a remainder of 7. When you very first learn to divide like this, your answer is something like 420 with a remainder of 7. Then you learn about what to do with that. So what we actually do with this is that we say that it is 420, and then we have a fraction. What goes on the numerator? 7 and 13 in the denominator, right? So I get 420 and 7/13. If I have 420 and I have 7/13, what do I do with those two values to get my actual answer? Like it's 420, and when we say and 7/13, what does the and mean we're doing with it? Adding, okay? So we don't put a plus sign because it's a fraction, and that's just how fractions work. But I want you to think about the fact, because it's going to make a difference here with the polynomials, that we take whatever this is, and then we add the remainder. Okay? You don't put a plus sign here because it makes no sense, but it will need to make sense for this over here. Okay? We good? All right. So let's try one of these. We're going to take this x plus 4, and we're going to divide it into... Oh, not a square root. Good Lord, what is wrong with me? Divided into 3x cubed plus 2x squared minus 37x plus 12. Okay. All right. So even though we took the entire 13 and tried to divide it into 54, we don't take the entire x plus 4 and try and divide it into this. We just look at this term and this term. So 13 divided into 54 is the same thing as saying 54 divided by 13, right? So if I take 3x cubed and I divide it by x, what am I left with? 3x squared. So since it's 3x squared, I put it above the x squared term, 3x squared. Then just like after we got the 4 up here and we multiplied it by 13 to get 52, I'm going to take this 3x squared and multiply it back. I do 3x squared times x is 3x cubed. 3x squared times 4 is 12x squared. And I make sure that my variables are lined up where they need to be. Then once we got the 52 over here, we subtracted it, right? This is 2 terms, so I would have to subtract the entire thing, which we can make it look like that, or we can do it a little bit differently. When we do this, we get 3x cubed minus 3x cubed, that zeroes out. 2x squared minus 12x squared is what? Negative 10x squared. And then I bring down my negative 37x. Then I keep going. Now I take this negative 10x squared and divide it by x. That leaves me with negative 10x. Multiply that back, and I get negative 10x squared minus 40x. And then I'm subtracting the entire thing. I highly suggest you don't just think in your head, I know I'm subtracting, right? Like here, what I have in green, you may not always write that because you just know you're subtracting. Over here, you better make note of it because the sign issues are going to be what are a problem for a lot of people. So negative 10x squared minus a negative 10x squared, those zero out. Negative 37x minus 40x is what? Negative 37 minus a negative 40 is the same as adding 40. You get 3x plus 12. Did most of you learn it where you put the parentheses with the negative? Okay. So another thing that you can do, and the way I normally teach it, but I did this just because I know I see that on a lot of papers, which is fine. I am not saying you have to change anything. But if the signs are going to mix you up, then I'm going to show you something different. I'm going to do the rest of them differently. If you keep doing it like this, knock yourself out. I'm totally fine with it. All right? So we're going to do x into 3x. This is going to be a positive 3, right? Multiply it back. So I get 3x plus 12. When you put this negative out here around the parentheses, it is the same thing as changing the signs on both of the terms, which is sometimes a little safer with the polynomials, okay? So I usually say you go in and you change the signs. It's like distributing the negative. So then these zero out, your remainder is 0. So your answer then is 3x squared minus 10x plus 3. So that means that this trinomial times this binomial would give me this cubic function. Okay? We good with that? Any questions at all? This is one where we could use synthetic division. Again, we'll talk about that tomorrow. But the next two on the front here, we could not use synthetic division. We would have to know how to do long division, right? I mean, you can force this one into synthetic division, but really it's not necessary because then weird things happen. So we're going to take 2x plus 7. We're going to divide it into 2x cubed plus 5x squared minus 19x minus 42. So this time, I don't have, my leading coefficient isn't 1, it's 2. But we work it the exact same way. I'm going to take this first term, 2x cubed. I divide it by 2x, and what am I left with? X squared. And I don't get to willy-nilly put x squared up there wherever I want. It goes above the x squared term. Then I multiply it back, x squared times 2x cubed, plus 7x squared. Then again, if you want to put the minus with the parentheses, that's totally fine, but it's the same as changing the sign on both of them. So then these zero out, and you're left with a negative 2x squared. Bring this down, minus 19x. So then I take negative 2x squared, and I divide it by 2x, and that leaves me with what? Negative x. So negative x times 2x is negative 2x squared. If these two things don't match, when you multiply it back, you made a wrong choice about what you were dividing and what you got. Okay, these should always match here. And then, let's see, and then negative 7x. So then I change the signs on both so that these zero out, and then I get negative 7, no I don't, I get negative 12. Negative 12x bring down the negative 42. Do you need to get the card out? Okay. She needs to drive that card out. Can y'all make some room? Like, spread the waters for her real quick. And it's probably easiest to come this way. There you go. You might need to move a little bit, hon. And you're probably going to need to move your backpack so she doesn't run over it. All right, so then negative 2x divided into negative 12x is a negative 6. So I multiply it back, and this is what I get. I change the signs, and this zeroes out. So my final answer then is x squared minus x minus 6. That is what I get once I divide it out. Okay? Everybody okay with that? So although we could force this into synthetic division, which you may have done in Algebra 2, because I do see that sometimes, I wouldn't suggest it. We could do long division here. You cannot force number 6 into synthetic division. So again, if the only thing we know how to do is long division, then that's what it's going to be. So we're going to take x squared plus 8, and we're going to divide it into x to the 4th plus 3x cubed plus 4x squared plus 24x minus 32. Okay, that's a lot. All right, so when I do this, start off the same way. X to the 4th divided by x squared leaves me with x squared. I put it above the x squared term. Okay. Multiply x squared times x squared, I get x to the 4th. X squared times 8 gives me a positive 8x squared, and I line it up with the x squared term. There's a big old gap there. You can't line it up with the x cubed because you can't actually subtract those. So then I change the sign on both. These zero out. This is like 3x cubed minus 0, so I bring down my 3x cubed. Then I have 4x squared minus 8x squared is a negative 4x squared. And then I bring down my positive 24x. Everybody with me? You got to line stuff up right. All right, so then x squared divided into 3x cubed is going to be a positive 3x. Multiply it back, and I get 3x cubed plus 24x. Change the signs on both. Those zero out. Negative 4x squared minus 0 is a negative 4x squared. These zero out, and I bring down my negative 32. Okay. Is everybody with me? All right. X squared divided into negative 4x squared is a negative 4. Multiply that back. Negative 4x squared minus 32. Change the signs on both and combine them, and I get 0 because they zero out. All three of these that we've done are remainder 0. It won't always be 0, but let's write this down and talk about what it means when it is 0. X squared plus 3x minus 4. That's what we get. So since the remainder is 0 every time, that means that this 2x plus 7, this is a factor of this polynomial. This is also a factor of this polynomial. If I didn't get 0, like this isn't a, when I come up here, I can tell you that 13 is not a factor of 5,467 because it didn't divide in evenly, right? It's not a number that you would think of to divide in. All right, any questions at this point before we move on to some other things that are happening? We good? Sign errors are the biggest thing here, and stupid mistakes like multiplying 2 times 3 and saying it's 5. I mean, that's just, you know, those are things that happen. All right, so we're going to have x plus 1, and we're going to divide it into 3x cubed plus 7x squared plus 2x plus 3. Okay. All right, so we're going to go about this the exact same way. 3x cubed divided by x is going to give me 3x squared. All right, 3x squared times x, 3x cubed, 3x squared times 1, 3x squared. Okay, I change the signs on both. Those zero out, and this gives me 4x squared plus 2x. 4x squared divided by x gives me positive 4x. So 4x squared plus 4x. And then I change the signs. These zero out. This gives me a negative 2x. This comes down, plus 3. So x into negative 2x leaves me with a negative 2. So you get negative 2x minus 2. Change my signs, and I get 5. Okay. Which means, just like we did here, we have what was on top right here, and then we have a fraction made out of these two pieces. And what did we say goes right here that's not really right here? Plus, okay? So when we come back over here, we're going to have 3x squared plus 4x minus 2 plus, I don't care what the sign is on this, you always add the remainder. Okay, so it's plus, then you got a fraction. The numerator is 5, the denominator is x plus 1. And that is your answer. Okay. What questions do you have? We're all good? All right, then you do number 8 on your own. Oh, what should this 9x squared be? Negative 13x squared minus a negative 4x squared. Yes. But it could be wrong. I'll walk away from up there and then I forget what it's supposed to be. I know that this is not the right number, so you can find a mistake for that. Okay, so the biggest issue that I've seen as I've walked around are sign issues, which is to be expected, so we want to be very careful with this. 6x cubed divided by 3x is 2x squared. I think we all pretty much got that. So then that gives me 6x cubed minus 4x squared. Then I change the signs on both. This zeroes out. This leaves me with a negative 9x squared. Bring this down, plus 12x. Okay, I've seen a positive 9x squared there, like a lot already so far today. So 3x divides into negative 9x squared. That's a negative 3x. So it gives me negative 9x squared plus 6x. Right? Negative times negative is a positive. I change the signs on both. This zeroes out, and I get 6x plus 6. 3x goes into 6x a positive 2 times. So this is 6x minus 4. Change the signs on that. Ugh. And I get 10. So my final answer then is 2x squared minus 3x plus 2 plus 10 over 3x minus 2. Okay? What questions you got? If all you did was make a sign error, the good news is you know what you're doing. The bad news is it still makes you wrong, and they are very frustrating. But it happens to everybody. You just have to, I mean, there's not like a fix for that. You just have to be more careful. I don't know what else to say. Any questions? Okay, so everything we've divided so far has been a binomial. We can also do this with a trinomial. So let's look at this one. So I'm going to have x squared minus x minus 5 divided into x to the 4th minus 5x cubed plus x squared plus 20x minus 10. Okay. You do it the exact same way. It doesn't matter how many terms there are. Okay, we take the first term, x to the 4th, divided by x squared. I get x squared. I put it above the x squared term. Then I multiply back and line things up. X squared times x squared is x to the 4th. X squared times negative x cubed. X squared times negative 5, negative 5x squared. Then I change the signs. These zero out. This leaves me with a negative 4x cubed plus 6x squared, and I bring down my 20x. If you continually make sign errors and you're doing the parenthesis with the negative outside, my suggestion is you change that and you literally change the signs on everything so you're less likely to mess it up. I'm not going to say it's guaranteed. All right, so negative 4x cubed divided by x squared is negative 4x. So negative 4x cubed plus 4x squared plus 20x. Then I change the signs on all of them. These zero out. This gives me 2x squared. These zero out, and I bring down my negative 10. Okay, and I leave a big old space there. Totally fine. 2x squared divided by x squared is a positive 2. When I multiply that back, I have to multiply by all of them. So 2 times x squared is 2x squared. 2 times a negative x is negative 2x. 2 times a negative 5 is a negative 10. Then I change the signs on each piece. These zero out, and these zero out. And what I'm left with is 0 plus 2x, which is just 2x. So my answer in the end then is x squared minus 4x plus 2 plus 2x over x squared minus x minus 5. Okay. What questions you got? Anything? We good? All right, so aside from sign errors, the next biggest problem with this, with people missing things, is when you have missing powers, which we haven't had yet, we're about to do that, and you ignore the missing powers. You don't get to do that. It's kind of like with this 420. I didn't get to just leave it as 42. right? And if I have a number like 408, I have a missing, my tenths place is basically missing, right? So that 0 is a placeholder because I don't have a value for the tens. We have to think about the same kind of thing when we look at the polynomials. So here we had a 4th degree, but notice my exponents are 4, 3, 2, 1, 0. All of them were accounted for. They all have to be accounted for when it's in the little house. Outside, it doesn't matter. We had missing powers, and it's fine. But instead, we have this x minus 8, right? It's going to divide into, all right, so this is x to the 4th. I don't have an x cubed term. I do have x squared, I do have x, and I do have one without one. So I have to have a placeholder for my x cubed. So x to the 4th plus 0x cubed. Okay, you have to actually have it in there. Then minus 64x squared plus 9x minus 80. Okay. Don't leave that off. Then you do it just like you do all the rest. X to the 4th divided by x is x cubed. I put it above the x cubed term, which I have because I put a placeholder in there. X cubed times x is x to the 4th. X cubed times negative 8 is negative 8x cubed. Change the signs on both. These zero out. And I have 8x cubed. Bring down my negative 64x squared. Okay, everybody with me so far? So then x divides into 8x cubed, 8x squared times. So this is plus 8x squared. So this gives me 8x cubed minus 64x squared. I change the signs on both. This zeroes out, and so does that. So I'm not going to have an x squared term to divide that into, so I have to bring down my 9x, and I have to bring down my negative 80, since I zeroed them both out. Then x goes into 9x 9 times, so I put that positive 9 over the negative 80, because I don't have an x term in my answer. So then I multiply it back, and I get 9x minus 72. Change the signs on both. Those zero out, and I get a negative 8. So when I rewrite this, I could write it as x cubed plus 8x squared plus 0x plus 9, but you'll never see it that way. You don't need to, but that's basically what's happening here as well. So my final answer then is x cubed plus 8x squared plus 9 plus whatever the remainder is, which is a negative 8 over x minus 8. In this particular case, would it be the same if I did minus and made this a positive? The answer is yes. Is it going to work that way for every remainder you ever get? No. So that you don't have to think about it and you don't get it mixed up, you always add the remainder and just take exactly what this is over exactly what that is, and you'll be good. Okay? What questions you got? All right, then you do number 11. What? Why it has to have a 0x cubed? Yeah, I just don't have an x cubed term, so I just put 0x cubed there. It's like here, this is cubed, x squared, there's no x term. Whatever's missing, you have to put in a 0 for it. That's it. And then you divide the exact same way. if you're not done, that's fine. But when you're done, check yourself with me. If we agree, then go ahead and fold and tape. If we don't agree and you have a question, let me know. When you do this delta math, you have to have paper. Do not even try and tell me you're doing this in your head, because you're not, okay? There's some stuff you don't necessarily need paper for delta math, but you need to actually practice the real steps, because I'm going to expect to see real steps when you take tests and quizzes.